Dawn at Vesta. Giuseppe Piazzi, Catholic priest, mathematician, and astronomer. The Celestial Police, a group of 24 astronomers organized in September 1800 to catch a missing planet that they thought should exist between Mars and Jupiter. They were scooped by astronomer Giuseppe Piazzi, who was unaware of their quest. On January 1st, 1801, Piazzi spotted a dim star in the constellation Taurus while working on a catalog that he would publish in 1803. When he observed again on the next night, he found that it had moved. He continued to notice position changes on January 3rd and 4th. He wrote to a number of his colleagues, including Johann Bode, director of the Berlin Observatory, to inform them of his findings. It was Bode, one of the Celestial Police, who had published a mathematical relationship of planet distances developed by Johann Titus that suggested a planet should orbit the Sun 2.8 times farther from the Sun than Earth. Bode then studied Piazzi's findings. He was certain that Piazzi had found the missing planet, even though no one besides Piazzi had seen the object. Piazzi knew stars are too far away to shift in 24 hours. He had also watched planets move across the sky: Venus and Mercury, Mars and Jupiter, and Saturn. This spot of light wasn't any of them. That this spot of light moved revealed that it was not a star, but an object within our solar system. What was it? Piazzi didn't collect enough data to determine the orbit, and thus it had disappeared. Was it lost? Others began searching for it, not realizing that it would be late fall until its return. A brilliant young German mathematician, Carl Friedrich Gauss, came to the rescue. He invented a new mathematical method that allowed him to compute the orbit using the limited observations available, and was able to predict where the new planet should be found. Then, on December 7, 1801, Baron Francis Xavier von Zach found 4 stars at the location Piazzi had previously observed. When the weather cleared on December 18th, one of the stars was gone. 1 year to the day of Piazzi's first observation, von Zach finally confirmed that he recovered the missing object Piazzi found. What was lost was now found. It was discovered that the object orbits the Sun between Mars and Jupiter. Was this Johann Bode's predicted planet? The object was named by Piazzi to be Ceres, after the Roman goddess of growing plants, the harvest, and motherly love. Ceres is the only dwarf planet and the largest asteroid in the inner solar system. Over the next 6 years, astronomers would discover 3 other similar objects, also orbiting in the region between Mars and Jupiter: Pallas, Juno, and the last of these received the name Vesta. These objects, and thousands of others that would be discovered more than 100 years later, were eventually called asteroids, from a Greek word meaning star-like, because of their star-like appearance. We have learned that asteroids are rocky objects. Astronomers think they are left over from material that was unable to collect into planets due to gravitational tug-of-war between massive Jupiter and the Sun. That means asteroids may contain clues about the conditions and processes acting during the solar system's earliest times. Asteroids are not identical. By analyzing sunlight reflected from Ceres and Vesta, astronomers can tell that their surface compositions are different from one another. By studying these 2 different asteroids in more detail, scientists hope to unlock some of the mysteries of planetary formation. The journey for a closer look at these two distinct worlds began in September 2007 with the launch of the Dawn spacecraft. Dawn carries a suite of cameras and other instruments designed to study each asteroid in detail. At each asteroid, Dawn's mission is to acquire color images, compile a topographic map, map elemental and mineralogical composition, measure the gravity field, and search for moons. Dawn's most unusual feature is its propulsion system. Invented by the Chinese about 1,000 years ago, ion propulsion is used instead of chemical rockets. Powered by the two large solar panels, xenon atoms are stripped of their electrons or ionized. This moves them out of the engine at high speed. The resulting pushback from the propulsion changes the speed and direction of the spacecraft. The propulsive force is small, equivalent to the weight of a single sheet of paper. But unlike chemical rockets that burn their fuel in minutes, the tiny force from the ion engine can be applied continually for years. The slow and steady tortoise-like ion engine is much more efficient than the hair-like rocket engine, and over a long time can provide a greater cumulative thrust. Upon its arrival at Vesta in July 2011, Dawn put its instruments to work. Spectacular images reveal a complex terrain and striking details in a huge basin deep in the southern hemisphere. Vesta seems more like a miniature planet than a rocky asteroid. Dawn's measurements suggest that it likely has a crust, mantle, and an iron core almost half its diameter. At the end of its time at Vesta, Dawn will do something no other spacecraft has ever done. While many robotic spacecraft have entered orbit about objects in our solar system, Dawn is the only spacecraft to get into orbit around a body other than Earth and then leave it to go into orbit around another target other than Earth. Dawn will leave Vesta in August 2012 and begin a 2.5-year journey to Ceres. What do we expect when Dawn gets to Ceres? Will it have moons?